We're going to talk about something called the chain rule today, and the chain rule is going to help us to be able to take derivatives of a lot of other functions that we wouldn't have been able to previously. And so before we learn what the chain rule is, we're going to do this very simple little exercise here. We're going to take the function 6x minus 10, y equals 6x minus 10, and we're going to write it out as a composition of two functions. So we're going to rewrite it as y equals 2u. And if y equals 2u, what would u have to equal?
3x
over 2. Oh.
Right, I'm not sure who said that, but yeah, 3x minus 5, right? If you factor a 2 out of this, you have 2 times 3x minus 5. So if u was 3x minus 5, then y equals 2u with u equals 3x minus 5 should be the same as y equals 6x minus 10. Everybody agree with that?
Yeah.
Yeah.
All right. Cool. So I'm going to ask us to find 3 different derivatives here. And all 3 of them we should be able to find. So what is dy dx? What's the derivative of y with respect to x? Well, that's just going to mean the derivative with respect to x of y when it's in terms of x. So what's the derivative of 6x minus 10?
6.
Should just be 6. So dy du then should be what's the derivative with respect to u of y when it's in terms of u. So that'd be the derivative with respect to u of 2u. What is the derivative with respect to u of 2u?
2.
Should just be 2. And du dx, which should just be the derivative with respect to x of u in terms of x, which is 3x minus 5. So what's the derivative of 3x minus 5 with respect to x?
3.
3.
And with any luck, you would hopefully see the relationship between dy dx, dy du, and du dx. 6 should equal 2 times 3, right?
Yep.
So dy dx, if we can write it as a composition of 2 functions, should equal dy du times du dx. That simple rule, which I've got written on the next page, is called the chain rule. And there's multiple different ways to write it out. I'll show you all the different ways to write it out. But the way we're going to notate it most of the time when we're taking these derivatives is dy dx equals dy du times du dx. And what we'll need to be able to do is we need to be able to write certain functions as a composition of 2 other functions. So here it is, dy dx is dy du times du dx. Sometimes it is written as f prime of u times g prime of x. This is a lot less common. This one over here is more common. So f prime of g of x times g prime of x. If we're writing it as f of g of x. And we'll not use this a ton right now, but as we get into talking about how the AP test sometimes, some of the types of questions that you'll see on the AP test, especially in the multiple choice, we often will use this notation to help us work through them. And so we'll practice using this notation also and see exactly what that means. But this is the chain rule, and the chain rule is, along with the product and the quotient rule, exceptionally important. And the chain rule is really like the most important rule because it allows us to take derivatives of so many other functions that we normally wouldn't be able to. So let's see if we can use the chain rule to find the derivative of this function, y equals 3x squared plus 1 all raised to the 2nd power. Now, before we do that, do I need the chain rule to solve this? Is there another way we could do it without using this chain rule with the composition of functions?
Yeah.
Yeah, there should be 2 different ways. One is we could write it as 3x squared plus 1 times 3x squared plus 1, and you use which rule?
Product.
product rule. Another is we could write it as 3x squared plus 1 times 3x squared plus 1 and distribute it all out and just use the power rule, right?
Yep.
But we're going to try and do this using the chain rule. So the chain rule says, let's write it as a composition of two functions. So what should y equal in terms of u? What is the innermost function of 3x squared plus 1 squared?
U squared.
Right, we're looking at a u squared with a u equal to 3x squared plus 1. Everybody agree with that?
Yeah.
All right, cool. So then we need to take the derivative of y with respect to u. What is the derivative of y with respect to u? What's the derivative of u squared?
U squared.
Right, but what's the derivative of u
well,
squared?
2x squared plus 1.
So the derivative of y with respect to u means take the derivative of u squared. Take the derivative of the function y when it is in terms of u. So y equals u squared will become dy du equals 2u. Everybody okay with that? Or any questions on that?
No. What?
Okay, so let's look back at the first one. Where we rewrote 6x minus 10 as y equals 2u with u equal to 3x minus 5. And we took the derivative of y with respect to u. Meant we took the derivative with respect to u of 2u. So the same thing here. dy du means take the derivative of y, which y equals two different things. Y is equal to 3x squared plus 1 squared, and y is equal to u squared. But when we want to take the derivative of y with respect to u, du, we have to use the one that has it written in terms of u. Everybody okay with that? Or no?
Yeah.
Okay. Then we also need to find du dx. And so du dx should be the derivative of our new function u equals this, with respect to x. So it's the derivative of u in terms of x. The derivative of 3x squared is
6x.
6x. Everybody good with that so far?
Yeah.
All right. So now we're going to have, if we do dy du times du dx, we should end up with 12x times u. Everybody agree with that?
Yeah.
Yeah.
All right. And 12x times u should be 12x times our u value, which was 3x squared plus 1. And that should be our derivative using the chain rule of 3x squared plus 1 squared. Any questions on that?
How do you determine u?
Sorry, say that again.
How do you determine u?
So, I mean, we just need to write this as a composition of two different functions, right? Our original function, 3x squared plus 1 squared. So, you mean down here, how do we determine u?
No, like originally.
Originally, yeah. So, we say usually it's whatever is inside these parentheses, whatever the innermost function is. So, like we have a function being squared. That's like the nature of this original y. It's some other function being squared. So there's two functions within there. There's the squared, and then there's the 3x squared plus 1. So the innermost one, 3x squared plus 1, becomes our u, so that we can write it as u equals 3x squared plus 1, with y equal to that u squared. Does that help and make sense or no?
Yeah, thank you.
Yep. All right, so from there, let's verify that this is right using the power rule. So to use the power rule, we'll distribute out the 3x squared plus 1 squared, which should give us 9x to the 4th plus 6x squared plus 1. Everybody agree with that? If you distribute that out?
Yep.
Okay. And if we take the derivative using the power rule, that should give us 36x cubed plus 12x. And if if you were to distribute out what we got in the red over here with the chain rule, 12x times 3x squared gives you the 36x cubed, and 12x times the 1 gives you the 12x. So either way works. Now we'll note that it might have been easier to distribute it out and use the power rule, but that won't be the case for every function. And there won't always be an easy way to check your work on it. You're just going to have to get used to using the chain rule. So I got a question sent to me. How did I get the 12xu? So our chain rule says dy du times du dx is our derivative. Dy dx is dy du times du dx. So we found the dy du to be 2u. We found the du dx to be 6x. And then we multiplied those together. So 2 times 6 is 12 with the x and with the u, all that being multiplied together. Does that make sense? Okay, cool. All right, any other questions on that? Let's see here. All right, let's try another one. So let's see if we can find the derivative of f of x equals sine of 2x. So the first thing we want to do is write this as a composition of two functions. So f of x equals sine 2x could be written as y equals the sine of what? How about sine of u, with u equal to that innermost function, 2x, where if we were to substitute the u value in, we'd end up with our original function. Everybody good with breaking that down into that composition of two different functions? Okay. So then we'll find dy du. So what's the derivative of sine u in terms of u?
Cosine u.
Cosine u. And what's the derivative of u in terms of x? Should just be 2. So dy du times du dx should be 2 cosine u, or 2 cosine, and we'll resubstitute the u back in as 2x. So we should end up with 2 cosine 2x. Any questions on that? All right, so let's see if we can go and expand out sine 2x using our trig identities and show that we get 2 cosine 2x. So what is the double angle identity for sine?
2 sine cosine.
Yep, 2 sine x cosine x. And so how will we take the derivative of that? What rule will we need to use?
The product rule.
Product rule, yep. Okay, so we'll start with 2 sine. So 2 sine x times the derivative of cosine, which is negative sine, and then plus the derivative of 2 sine, which is 2 cosine x, times cosine x. Everybody good with that so far? Yeah?
Yeah.
Okay. So what does that first part become? 2 sine times negative sine should be negative 2 sine squared.
Negative 2 sine squared x.
Yep. And the other should become plus 2 cosine squared x. And I could factor out the 2 from both of those. And if I write the positive one first, we got 2 times cosine squared x minus sine squared x. And with any luck, you know that cosine squared x minus sine squared x, because you memorized those identities I told you to memorize, cosine squared minus sine squared is equal to cosine 2x. So that should be the same thing. Everybody good there?
Yep.
All right.
I have a quick question.
Yeah.
When you found the derivative of 2 cosine. Well, yeah, it was 2 cosine x. Like, how did you get the plus cosine times 2 cosine x? It's like, why'd you keep the 2?
Over here?
Yeah.
Yeah, so I treated it as if my u was 2 sine x and my v was cosine x. So u, 2 sine x, derivative of v, plus derivative of u times v, right? The derivative of 2 sine x is 2 cosine x.
Okay.
Does that make sense or no?
Why do you get to keep the 2 when you find the derivative of 2 sine x?
I mean, that's just a constant out in front of it, in front of the 2 sine x, which was our first function. So the function itself is sine x. The base function within there is sine x, and it's being multiplied by a constant. So we had a rule way back when that the derivative of a constant times a function is the constant times the derivative of the function.
Okay.
Like if we have, what's the derivative of, 2x squared, that is 2 times the derivative of x squared, or 4x. Does that make sense?
Yeah.
Okay. Any other questions on that one? All right. So here I'm going to give us a position function. So we got a position function here. X of t is equal to cosine t squared plus 1. And we want to find the velocity function. So we'll remember we talked about the other day. If we have a position function, how do we find the velocity function? We take a
Derivative of the position function.
x prime should be v of t. And so how are we going to figure that out? We need to use the chain rule, and we're going to write this as our function. We'll just say y equals cosine of u with u equal to t squared plus. Everybody good with that?
Yeah.
Yeah.
All right, so using the chain rule, it should be the derivative of this first one in terms of u. So what's the derivative of cosine u? It should be negative sine u. And then we'll take the derivative of this one. And what's the derivative of t squared plus 1?
2t.
2t. So we end up with negative 2t sine of u, and u was t squared plus 1. Any questions on that? Everybody okay with that?
Yeah.
All right, let's do another one. I want to differentiate sine of x squared plus x. So in terms of u, what does y equal? Y should equal
Sine u.
sine u with u equal to x squared plus x. So our derivative should be dy du, which is cosine u times du dx, which is 2x plus 1, or 2x plus 1 times the cosine of x squared plus x. Good or no?
Yeah.
All right, now, so for the next day or so, I'm going to give you a chain. I'm not going to give you a chain rule assignment today because we're not going to get through all of it anyway. But when I give you a chain rule assignment tomorrow to practice, I want you to write out your composition of functions, y equals whatever with u equal to whatever it happens to be. But after that, I would hope that you all start to get to the point where you can just do these ones in your head. I don't expect you to do that right this second. If you can, that's great. But within the next couple of days, I would expect you to get so used to using the chain rule over and over again that you can do them in your head and just go straight from you know, what's the derivative of sine x squared plus x? Oh, it's 2x plus 1 times cosine x squared plus x. That's my hope. You will be able to. All right, let's find this one. What should y equal?
Square root x.
Square root
Square root u.
square root u. And what should u equal?
X squared plus 1.
Squared plus 1. So what's dy du?
One over 2 root u.
Yep, that's one of the ones I told you guys to memorize, right? Square root of u's derivative is 1 over 2 root u. And what's du dx?
2x.
2x, right? And so we'll multiply those together to get 2x over 2 root, and we'll replace the u with x squared plus 1, cancel out the 2's, and we got x over root x squared plus 1. Any issues with that?
Nope.
Nope.
All right, why don't you guys see if you can figure this one out on your own. Take a minute or two and see if you can write this as a composition of two functions and then take the derivative. How's that going? You guys doing all right with that or no?
Yeah.
Yeah.
What was the y equals that you guys used? Y equals what?
1 over x cubed.
1 over u cubed.
Or what? 1 over u cubed, yeah.
1 over u cubed, or you might have written it as u to the negative 3. Right? Either one of those would be fine. For one, you could use the reciprocal rule. For the other, you could use the power rule. And we'd have u is equal to 4x squared plus 6x minus 7. Everybody good there?
Yeah.
All right. So it doesn't really matter which way you went. You get the same result using either. I'll just use this for the power rule. So dy du should have been negative 3 u to the negative 4. And du dx should have been 8x plus 6. Everybody agree with those?
Yes.
And then we'd have -3 over u to the 4th. So that'd be 4x squared plus 6x minus 7 to the 4th power times this 8x plus 6. And if you want to factor the 2 out of there and have a -6 times 4x plus 3, that's fine. But if you don't, it doesn't really matter. Any questions on that? Everybody good with that?
Or could we multiply the -3 times 8x and times 6?
Sure, if you want to. No reason to do that, just like there's no reason to factor the 2 out particularly. I'm not going to grade you down for not factoring little things out or not distributing things through all the way unless I specifically tell you to do it, and the AP test won't require you to either. So if you want to, go for it. If you don't, don't. All right, I think that's a good spot to stop. We'll practice some more with the chain rule tomorrow. And also tomorrow, we're going to start talking about how to find the derivatives of exponential functions and hopefully logarithmic functions and also hopefully inverse trig functions. And we'll have quite a bit to do with that. And you'll get an assignment that may be due tomorrow, but may not be due till Wednesday, depending on how much we get covered tomorrow. So any questions on this from today? Okay, if you finish up your trig assignment early and have some spare time, take a look at the next couple of these that are in the notes and see if you can just work on solving them on your own. And then we'll, I'm going to do them all tomorrow anyway, but a good practice just to see if you got the chain rule down. So the notes are posted in Google Drive, so you should be able to take a look at the rest of this set of slides and try and solve the problems that are in it if you want to get that extra practice in, that'd be good. Other than that, I think we're done.